Alright, so this question is sort the metric diagonally. So you're given the metric n by n, doesn't matter like how what's the size of the metric. It could be this, like a 30 metric or not. But I'm going to use my own word to explain that what's going on. So you get a metric, and this is your diagonal value. You grab everything from the diagonal value, and then you sort it. So the value, it should be 1, 2, 3. So this is a sort value, and you place the smallest in the beginning, and then so on, right? So this will be 1, 2. So the idea is pretty straightforward. We traverse the metric, and then we grab the diagonal value, and then we place them back, and then we go on the next diagonal, and then so on. So as you can tell, like this position is actually 0, 0, right? And this position is 0, 1, 1, 1, sorry, 1, 1. This position is 2, 2. How about this one? This is what? 0, 1. This is what? 1, 2. This is what? 2, 3. So if you can use the elementary math to find out the slope, or like anything, it should be like rise over run, something like this, right? Since we cannot divide by 0, so we can use another trick using what? I minus j. So I minus j will be the unique value for diagonal, right? So let's look at this. All right, let's look at the 0, 0. 0, 0 minus 0 is actually 0. 1 minus 1 is actually 0. 2 minus 2 is actually 0. So these are all the same slope. What happened to here? 0 minus 0, 1, right? And then 1, 2, and 2, 3. So that's 1 minus 0 minus 1 is what? Negative 1. 1 minus 2 is negative 1. 2 minus 3 is negative 1, and then so on. Everything should be straightforward. Like if you have any question related to your elementary math, just go on Google. Alright, so what you need to do is you want to know what's your current diagonal value and what are the diagonal values, right? So we need to get a diagonal label. So this is the diagonal label. Diagonal label I minus j. Diagonal value, this is gonna be list of integer, right? So let's look at this. I'm gonna hash map, select the integer, and this will be list, right? But at some point we need to sort it, right? So once we finish the diagonal traversal, we need to sort it. So it's better to use a priority queue right over here. So when we add, it's already sorted, so we don't have to worry about that. Hash map. Alright, so we need to traverse. In there. Come on. Alright, so now we can actually, initialize my priority queue for my first key. So it's going to be compute if absent, and it's going to be I minus j, right? I minus j, and I'm going to initialize my priority queue, priority. Alright, now I'm going to add the the value, right? It's going to match at I and j. So I will traverse back. Traverse again my 2D metric, and I'm going to say, what are the the smallest value in the priority queue for the current slope, and I'll just keep moving on, right? So it's gonna be for in I equal to 0, I less than. It's gonna be the same idea, but come on. So my mat at I and j will become what? The slope I minus j dot pull. So it will pull from the smallest. by default, right? I didn't change the constraint for the priority queue, so it should be smallest to greatest. So once I get a smallest value for the current position, I go on the next value. This will be next another diagonal value, then this will be another, and then back to here, back to here, back to here, and then so on and finish. So it should be straightforward enough. So compute if absent, what was the problem? Illegal store expression. Yes, I forgot to put a new. And yeah, pretty much. Alright, so let's look at time and space. This is a space, right? So how many elements we need to store in the hash map? Like, you don't worry about the priority. Priority queue is a list of the diagonal. So all of the value are going to put into the hash map, right? So it's going to be all of m and right, the size of the metric. How about time? Time is all of m, this is all of n, and the priority queue, right? So it's going to be what? Mn log between the size of the length of the metric or the column. So this will be the time and space for this solution. So the reason why you have the minimum for the time is going to be, so this metric is what? The column, the number of a column is more than the number of row, right? So what happens if you have more rows but less column, right? So this will be another scenario, but it's going to be based on your minimum. Like it should be based on minimum. All right, so there's another solution which can improve the time and space. So we don't actually need to create a hash map to collect every element diagonally and then sort it and then place it back. We can actually going through. So if you look at this metric, I'm going to just for example 1. So if we look at this metric, we started from here. This diagonal is coming back here, right? Why my computer is lagging for no reason? Alright, one more time. We started from the 0, 0, and the diagonal is like this, right? And then if I want to look at this diagonal is going to be this, and this will be this, and this will be this. Alright, just just look at this. So this will be the first diagonal. The second diagonal is going to be this, this. So if you notice, we always start in either the first column or first row, right? So this will be a trick to save the space because we know that what are the current diagonal we traverse. So I'm going to just write for in row equal to 0, row less than meta length, and row plus plus. So I can actually say update my diagonal, for my row, right? So if I keep switching the row, right, the diagonal always starting the column 0, right? And I'm going to do the same thing for the column equal to 0, column less than meta 0.length, column plus plus, and then update diagonal map. So your row will always remain 0, right? Your column changes. And then if you notice one trick, if we're starting here, this is row, we're starting in row 0, row 1, row 2. And then what happened to column? We're starting at column 0, column 1, column 2. We're actually doing twice for row 0, right? So we can actually starting from here, and then we can return that. Alright, now we just need to write the update diagonal map, and I'm going to say in row in column. So what you need to do, what you need to be aware is like the value for the mat is between what 1 to 100. So I'm going to have a collection, say counting to a new int 101. So I'm going to create a temporary value R and C. You can say X and Y. Let me say X and Y, so just in case. So I'm traversing my X and Y diagonally. Okay. So you will, I will explain why do you need to create a two variable, but here we go. So X has to be less than what? Meta length, and Y has to be less than meta 0.length. So I'm going to collect the value X and Y plus, right? Whatever the value in the metric, I increment the frequency, and X plus, Y plus. Alright, so now we're actually out of bound, right? Now we need to reinitialize. We need to reinitialize to the beginning, right? To the beginning for what? For actually reset this value correctly. So we have a frequency ready, and we just have to traverse all the way from 1 to 100, right? So it would be better to use counting array I length. Alright, if a counting I is actually equal to 0, we can discard. If not, then we want to know like how many how many frequency for this current index, the current value, because you could have what 2 2 2 or what 2 2 1, so you have 2 for 2, right? You want to know like, well, my counting I is greater than 0. You want to keep traversing and then keep replacing, right? So it's going to be mat at X and Y is equal to I, and then I'm going to say increment my X, I increment my Y, I decrement my frequency, right? So you are not in the loop. So this will be the solution. Let me run it, see if I have any error or not. Okay, so yeah, what I'm doing, decrement my frequency. So this is the frequency. Alright, so yeah, a little bit, improvement for the time. So let's look at the time and space. This is all of M, right? Rule all of N and M, right? So let's look at this. Update diagonal. This is a space, right? This is a diagonal. It's going to be between the minimum between your what? Your row or column, depending on your metric. And this is going to be constant. It's going to be 101 only. So the worst case for this is going to be all of M, this guy, N, this guy. So yeah, it's my note, whatever you think about this, but D represent diagonal, right? It's going to be the minimum between the M and N. So this will be the solution. So yeah, there's pros and cons. This is actually more efficient, but it's not readable. Compared to this solution, it's actually more readable for sure. It's all up to you. Whatever you think is correct is correct. Okay. So if you have questions, leave a comment. I'll see you later. Bye.